Here's a mind-bending fact that'll ruin your sleep tonight. The biggest thing in the universe isn't a thing at all. It's nothing. Absolutely nothing. And I'm not being philosophical here. I'm talking about actual, measurable, terrifyingly vast regions of space that make our entire galaxy look like a grain of sand on a beach that stretches across multiple continents. Right now, you're sitting inside one of the most massive structures we've ever discovered, and you've probably never even heard of it. Forget black holes, forget galaxy clusters, forget everything you think you know about cosmic scale. Because what I'm about to show you is so incomprehensibly large that it literally breaks our understanding of how the universe should work. And the craziest part? It's mostly empty space. So, buckle up, because we're about to journey into the voids, the cosmic abysses that actually rule our universe. Let's rewind to the mid-1980s when astronomers thought they had the universe pretty much figured out. Back then, the reigning champions of cosmic enormity were superclusters, these absolutely monstrous structures containing tens to hundreds of thousands of galaxies, stretching hundreds of millions to even billions of light years across space. To put that in perspective, light traveling at 186,000 miles per second would need billions of years to cross just one of these bad boys. Our own Milky Way? Yeah, we're just one tiny member of the Laniakea supercluster, which is Hawaiian for immeasurable heaven. Pretty fitting name, right? Laniakea contains about 100,000 galaxies, including our own, the Andromeda Galaxy, and pretty much everything you can see with even the most powerful telescopes available to backyard astronomers. For decades, scientists believed these superclusters were the final boss of cosmic structures, the biggest organized things that gravity could possibly build. They imagined the universe as this grand tapestry of superclusters, spread relatively evenly throughout space, like cities dotting a vast cosmic landscape. It was a comforting thought, really. The universe seemed comprehensible, organized, almost cozy. But here's the thing about the universe. It absolutely loves to humble us. Just when we think we've got it all figured out, it pulls back the curtain to reveal something so bizarre, so unexpected that it forces us to tear up our textbooks and start over. And that's exactly what happened in the late 1970s when a couple of astronomers decided to make a map. Little did they know, their map was about to reveal that we'd been staring at the cosmic picture completely upside down. In the late 1970s, two astronomers named Laird Thompson and Stephen Gregory were doing what astronomers do best, staring at the sky and making meticulous notes about where galaxies were located. But these weren't just random observations. They were creating what they called pizza slice maps of the universe, wedge-shaped sections showing galaxy positions at various distances from Earth. Imagine cutting a slice from a pizza and looking at how the toppings are distributed, except this pizza is the entire observable universe. Sounds delicious and existentially terrifying at the same time, doesn't it? What they found near the Coma cluster completely broke their brains. There was this massive region, and I mean massive, where there were just no galaxies. Nothing. Nada. Zip. It was like someone had taken a cosmic eraser and just wiped out a huge chunk of space. At first, they thought their equipment was broken, or maybe they'd made some catastrophic error in their calculations. Because according to everything astronomers believed at the time, this shouldn't be possible. The universe was supposed to be relatively uniform. Galaxies should be sprinkled throughout space like stars in the night sky, maybe with some clustering here and there, but certainly not with gigantic gaps of absolute nothingness. Other astronomers rushed to verify their findings, and guess what? Thompson and Gregory were right. In 1981, another enormous void was discovered, the Boots Void, sometimes creepily called the Great Nothing. This thing was roughly 330 million light-years in diameter, and it contained maybe 60 galaxies where there should have been around 2,000. That's like showing up to a packed stadium concert and finding only about 30 people scattered in random seats. Something was very, very wrong with our understanding of the universe. Or rather, something was very, very right about the universe that we'd gotten completely wrong. These discoveries completely obliterated the old model of a uniformly distributed universe. Instead, what emerged from the data was something far stranger and honestly kind of beautiful in a terrifying sort of way. The universe isn't evenly filled with galaxies at all. Instead, galaxies form what we now call the cosmic web. Imagine soap bubbles stacked together, where all the material clusters along the thin films and edges where the bubbles meet, while the insides of the bubbles are almost completely empty. That's basically the structure of our universe. Galaxies cluster into filaments and nodes like glowing threads in a vast spider's web, and these structures outline enormous bubbles of emptiness that we call voids. And here's the kicker that'll really mess with your head. Voids aren't rare cosmic curiosities that we occasionally stumble upon. They're actually the dominant feature of the universe. Most of the universe's volume is void. Let that sink in for a moment. The stuff we care about, planets, stars, galaxies, everything we can see and touch and measure, all of that exists only along the thin boundaries of these cosmic bubbles. We're essentially living on the surface of a foam of nothingness. Surveys like the Sloan Digital Sky Survey have now mapped tens of thousands of these voids, and the picture that emerges is stunning. The universe looks like a three-dimensional spider's web of light surrounding immense hollows of darkness. These voids contain less than 20% of the average cosmic density of matter, and that includes the mysterious dark matter that we can't even see. To put this in perspective, if you were somehow transported to the center of a large void, you might not see a single galaxy in any direction for hundreds of millions of light years. The night sky would be almost completely black, just a handful of dim smudges in the distance. It would be the loneliest view in the entire universe, and ironically, it's the most common environment in all of existence. So how did the universe end up looking like cosmic Swiss cheese? The answer takes us all the way back to the beginning, the Big Bang itself. Right after the Big Bang, the universe wasn't perfectly smooth. There were tiny fluctuations in density. Some regions had just slightly more matter than others, and some had slightly less. We're talking about differences of maybe 1 part in 100,000, ridiculously tiny variations. But here's where gravity enters the picture and absolutely runs wild with these tiny differences. Gravity is a greedy force. It pulls matter toward matter. So regions that started out with even slightly more matter began attracting more and more material from their surroundings. Meanwhile, the regions with slightly less matter, they got drained. Matter flowed out of these low-density regions and toward the high-density regions, like water flowing downhill. Over billions of years, this process accelerated. The rich got richer, and the poor got, well, empty. The voids expanded and merged, growing larger and larger like bubbles combining in a foam. Cosmologists now use what's called a watershed model to define voids. Think of them like drainage basins on Earth, the valleys between mountain ranges where all the water flows away. Except in this case, the water is matter, and it's flowing toward the mountains of galaxy clusters and filaments. And here's where things get even weirder. Inside large voids, there are smaller subvoids, and inside some of those, even smaller subvoids. It's a fractal hierarchy of emptiness, like Russian nesting dolls, except instead of dolls, it's just increasingly smaller bubbles of nothing inside bigger bubbles of nothing. The universe apparently has a twisted sense of humor and really loves the concept of nothingness nested within nothingness. Just when you thought voids couldn't get any more mind-bending, let me introduce you to supervoids, the heavyweight champions of cosmic emptiness. These are voids so enormous, spanning billions of light-years across, that they might actually be influencing the cosmic microwave background radiation, the ancient light from the Big Bang itself that fills all of space. One of the most famous examples is the Eridanus supervoid, which might explain one of cosmology's most perplexing mysteries, the cold spot in the cosmic microwave background. This cold spot is a region of the CMB that's significantly cooler than its surroundings, and scientists have been scratching their heads about it for years. The Eridanus supervoid sits in the same general direction, and some researchers think that light from the Big Bang lost energy passing through this enormous empty region, creating the cold spot we observe. It's like the void is so vast that it leaves a shadow in the oldest light in the universe. Then there's the giant void and the seriously controversial KBC supervoid, named after astronomers Keenan, Barger, and Cowie who proposed it. The KBC supervoid is potentially the most troubling discovery in modern cosmology, because if it's real and as large as some data suggests, it threatens one of the fundamental assumptions we make about the universe, the cosmological principle. This principle states that on large enough scales, the universe should look roughly the same everywhere. It should be homogeneous. But supervoids billions of light-years across? That's pushing the limits of what homogeneous can possibly mean. If these structures are too large, they could force us to rethink our entire standard model of cosmology, including how we measure the universe's expansion. Some scientists argue these supervoids could even explain discrepancies in our measurements of the Hubble constant, the rate at which the universe is expanding, which has become one of the biggest headaches in modern physics. Are we living inside a supervoid that's messing with our measurements? Is the universe not as homogeneous as we thought? Or are these apparent supervoids just statistical flukes, quirks of how we're analyzing the data? The debate rages on, and honestly, the uncertainty is both terrifying and exhilarating. Here's the truly sobering conclusion to our cosmic journey. The universe isn't dominated by galaxies, stars, or any of the spectacular structures we love to photograph and study. It's dominated by nothingness, and that nothingness is winning. As the universe continues its relentless expansion, accelerating, in fact, driven by the mysterious dark energy that makes up about 68% of everything, the voids will grow larger and larger. The cosmic web is being stretched like a rubber band, and eventually it will tear apart. Billions of years from now, the filaments connecting galaxy clusters will thin and break. Galaxy clusters will become isolated islands of light in an ocean of expanding darkness. And as the expansion accelerates further, even these islands will drift apart, each cluster becoming a lonely outpost in a sea of void that stretches for incomprehensible distances in every direction. Our distant descendants, if any exist, might live in a universe where the night sky contains only the galaxies in their local cluster, with nothing else visible for billions of light-years in any direction. They might not even know that other galaxies exist beyond their cosmic horizon. The evidence of the broader universe will have literally expanded away from them. And even further in the future, those local galaxies will merge, stars will die, and eventually even those final islands of light will fade to black. The voids will have won completely, leaving behind a universe that is, for all practical purposes, infinite emptiness, with only the rare quantum fluctuation to break the monotony. It's the heat death of the universe, and ironically, it returns the cosmos to something resembling its beginning, vast, dark, and nearly uniform. Except this time, there's no Big Bang waiting to restart the show. So there you have it. The biggest things in the universe are actually the absence of things. Voids that make our entire galaxy look like a speck of dust. Structures so vast they challenge our understanding of cosmology itself, and a future where emptiness consumes everything. If this video blew your mind even a fraction as much as researching it blew mine, do me a favor and smash that subscribe button, because we're just getting started on this journey through the weird, wonderful, and occasionally terrifying cosmos. And here's a question for you. If you could explore any void in the universe, which would you choose, and what do you think you'd find there? Drop your answers in the comments below. I read every single one, and some of you come up with theories that are honestly better than what the professionals publish. Thanks for watching, and remember, in space, no one can hear you scream into the void. Mostly because the void is just really, really big. See you on the next video.